that it belongs to the definition. Non-terminating means not ending. So any non-terminating decimal would be considered irrational. Terminating decimals are rational. And if I want to classify these numbers by their sets, I'm going to start with the biggest set of numbers that they belong to and try to classify them from the outgoing, or from the center going out. So the opposite of the square root of 36 would be an integer, rational, and real number. 21 would be a natural. Then that's also, you see it's in the whole numbers. It's also an integer, it's also rational, it's also real. Square root of 3, something I don't know much about. 9, and it's a negative number, and it's -5. So negatives always begin in the integers. 1/2, rational, becomes 11. It's an integer. 1/3, that's a fraction. It's a nice fraction, something we know something about. All these square roots. But not every square root. You can see those that are perfect squares belong in other sets over here. And our last one is rational. We want to name the sets of numbers to which number belongs to. So I would have you at this time write some numbers and check your answers. So I will just write some numbers here and have you give you a moment to check yourself here as you're working. So we'll start with -5. Number 1, I'll give you just a couple here. Number 2, give you 5 numbers to work with. Number 2, classify the number 10. Number 3, let's classify the square root of 35. Number 4, 17.238 ... and 5 will be square root of 4/3. I'll give you a moment to classify those. Alright, so if we're looking at just the number 5, and I wanted to, or -5, and I want to most define it, I would say that -5 is an integer, it is rational, and it is real. Integer, rational, real for number 1. Number 2, the number 10 starts at the natural numbers, so I would say that it is natural, whole, an integer, rational, and real. I just follow those arrows right up. Find where it starts and just follow them up. The square root of 35, I don't know what that is, so the square root of 35 would be an irrational number and a real number. 17.238 ... That ... there's no pattern here, it just tells me it's going to keep going on and on. Therefore it would be non-terminate, irrational, and real. The square root of 4/3. Square root of 4 is 2. So if I was going to simplify this, I would say that it is 2/3, 2/3. 2/3 is rational and real. Determine which set of numbers is most reasonable for the situation. So once again, I'm looking for the set of numbers, so the number of dolphins in the ocean, the height of a basketball player, the number of pets you have, circumference of a compact disc, your shoe size, and the number of siblings you have. You need to just think about these types of numbers and see what sets they belong in. The number of dolphins in the ocean, can I count that? Can I find that number? Yes. Is it going to be a nice number? Yes, there's not going to be part of a dolphin out there. Therefore, it would be natural, whole, integer, rational, and real. The height of a basketball player. Am I talking feet, inches, centimeters? I would say that if I'm doing feet, it would be some number of feet and then a part of a foot. For instance, if you were 6.5 feet, you'd be 6 feet 6 inches, so 6.5 feet. Therefore, it would be rational and real. The number of pets you have would be a nice number. I could count that. It would be natural, whole, integer, rational, real. Circumference of a compact disc is going to be rounded. It's going to be a decimal. Therefore, it'll be rational and real. Your shoe size. Your shoe size could be a half, it could be a whole, depending on what it is. But that number could be rational and real, or it could be a natural, whole, integer, rational and real. And the number of siblings you have will be, depending if you have some or none. If you have 0, it would be a whole number, integer, rational, real. And if you have at least 1, then it would be natural, whole, integer, rational, real. So, true or false, let's look here. All rational numbers are integers. So are all rationals integers? No, that is false. A rational number could be 1/3. That is not an example of an integer. All natural numbers are whole numbers. Are all the naturals whole numbers? Yes. That is true. All irrational numbers are real. Are all these irrational numbers in the real numbers? Yes, they are. Any number is a real number. All irrational numbers are whole. No, that is false. They're not associated at all. And some closure. Explain closure to a partner or to yourself. What is the difference between a whole number and a natural number? And then jot down a different example for each of the following: real, integer, or natural. I'll give you a few minutes to do that and to check yourself. So the difference between a whole number and a natural number: whole numbers include the number 0, where the natural numbers do not. And there are many examples. You could infinitely write numbers for the real numbers. Integers would be those negative numbers and the positive counting numbers, including 0. So you might have -13, 27, 143. And the naturals are just positive, nice numbers, counting from starting with your fingers and your toes. So 1, 2, 3, 472, 10,000,001, and so on. That concludes our lesson for today. Thank you very much. We'll see you in our next lesson.